Hi NEET aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்க. எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Hi students, yesterday we discussed chemical kinetics. What is the rate of reaction? Rate of reaction means concentration, change in concentration of product or reactants or product with respective to time. Already in first class I explained. Today we have to explain instantaneous rate of reaction, average rate of reaction. What is average rate of reaction? The rate of reaction measure certain period of time during the course of reaction, that is called average rate of reaction. What is average rate of reaction? The rate of reaction can measure certain period of time during the course of reaction, that is called average rate of reaction. What is instantaneous rate of reaction? Instantaneous means the rate of reaction can be determined at particular instant during the course of reaction, that is called instantaneous rate of reaction. We can observe the graphical representation average rate of reaction and instantaneous. We can draw the tangent at particular point t, we can get the instantaneous rate of reaction. We can write the graph. First one here is reactants versus, the two graphs are there. One is reactants, another one is the products. Here is reactant concentration. I am writing R, reactant concentration. Here is time. Another graph also. Here is product concentration. Here is time. Here this area time is increasing, and initially R0 means initial concentration of the reactant. The concentration of reactants decreases during the course of time. When time increasing, the concentration of reactants is decreasing. How decreasing? Here is the initial, it can be decreasing like this. The concentration of reactants can be decreases. The concentration of products can be increases. Now here I am taking R1. This one is the R2. Here is, that is the point T1. Here is R2, that is T2. Now T1 and T2, the difference is delta T. Now R2 minus R1, that is the delta R. Now average rate of reaction, I am writing average rate of reaction, R average, that is equal to minus delta R by delta T. Why I am writing here is minus? Because reactant concentration is decreases. When time increasing, reactant concentration decreasing. That's why minus delta R by delta T. Now write minus, that is equal to R2 minus R1 by delta T means T2 minus T1 for average rate of reaction. This is the average rate of reaction. For example, if you draw the tangent at a particular point T, this point is T, I am writing. I draw the tangent at a particular point T, we can write the, here is dr, this one is dt. Now slope is equal to, what is the instantaneous rate of reaction? The rate of reaction measured at particular point during the course of reaction. Here I am taking one particular point T. Here is slope is equal to, what is the instantaneous rate of reaction? Instantaneous rate of reaction, R is equal to minus dr by dt. Minus dr by dt, that is equal to negative slope will come. At particular point I am taking, that is the T. We can measure the at particular point, and time also here to here, and this distance. that is the dr by dt. Instantaneous rate of reaction means the rate of reaction can be measured at particular point during the course of reaction, that is called instantaneous rate of reaction. Here is concentration of reactants are decreasing when time increasing. Here is concentration of products are increasing. Here I am taking P1, here I am taking P2, from here to here that is the T2, and here is P1, this one is the T1, that T1 to T2 delta T, now P2 to P1 that is delta P. Now average rate of reaction that is equal to delta P by delta T, delta P by delta T. Now here is delta P means product concentration increasing when time increases. Now delta P by delta P that is equal to P2 minus P1, the concentration of P2 minus P1 by that is T2 minus T1. This is the average rate of reaction for delta P. We are using plus because the concentration of products are increasing during the course of reaction increasing. Now at particular point I draw the tangent at a particular point, and now here dt here is dp. Now instantaneous rate of reaction, that is R is equal to dp by dt, that is equal to positive slope. At particular point I am writing here one particular point to t. We can measure what is the instantaneous rate of reaction. The rate of reaction can be determined at particular point during the course of reaction. We draw the tangent at particular point, that is slope is equal to positive slope, and this one is the negative slope. What you understand from this graphical representation, the reactant concentration during time increases means reactant concentration is decreasing and product concentration increases. From instantaneous reaction, at particular time, at particular point, you have to determine the rate of reaction and use this graphical representation. It will be useful understanding for an average rate of reaction and instantaneous rate of reaction. Thank you, and subscribe it and comment it.